Right there. Do you see the little microphone?
Yeah.
If it's black, it's working. If it's gray, it's off. That it's black now, you are in charge. And you're in charge of making sure she's in charge. Because nothing's more pointless than a video that has no audio.
Subtitles, you just go over it again.
Okay. Like, I even thought, well, I probably got enough that we at least know where we are. But the entire part where we turned to the homework page and worked for 20 minutes on that, it's me doing it, but there's no reference on where we are. It's just me looking really not good in film. So anyway, hello kids. I'm not going to mute it today. That's my plan. I'm just going to pause it. But if I reach up, you say, hey, butt face, don't touch that button. Practice.
Don't touch it. I'm not going to call you a butt face.
I'm giving you permission. Would you call me a butt face?
Hey, butt face.
Okay, ready? I need someone more like Liam. You know, let's hear it.
Hey, butt face. Don't touch that.
I'm glad we have the sound studio.
Thank you for being kind. Thank you for being loud. All right. Do we have these two answered? They're a little tricky-ish, maybe. Will you point on your finger where they are, and I'll walk around and see if you got them. If you didn't write them anywhere, then just look happy. If anyone was paying attention, where's the only place I told you not to write your answers? On your periodic table. Still love you, though.
Thanks.
Good. Now, bond types, too.
What?
What would be the bond types?
Oh. Oh, crap, I forgot.
I told you to be time. When you were walking out yesterday, did you say, now I think I'm more confused than when I... Is that you? Someone said something like that. I'm going to mute this.
Please.
We're unmuted, right? Okay, here we go. Most people, you do okay, not fantastic, but it's doable. Here's the thing. I asked you to do two things in each question. This one right here, the bond type, is way more important that you're good at than the other one. So as long as you got those two right, you're actually probably fine. So first off, SR. To find the bond types, SR is what number? It's electronegativity. 1? Well, that was easy. And F is 4, right? 4 minus 1 equals 3. And 3 would make it a what? Ionic. What about that 2? For this, it doesn't matter, right? We don't care about it. So it's ionic. Who had ionic at least? Raise your hands. Keep them up. Okay, awesome. All right, I'll do the dots in a second. Let's do this one. 2.5 maybe and 2.8. Is that this one? 2.8. The difference is equal to 0.3, and that's less than 0.6. So this is a nonpolar. Who had nonpolar? So you were gone yesterday, right? You're caught up. Not bad, right? Like there was some deep stuff, why and all that, but if you can do this, you're good enough. Nonpolar. So now the dots. The dots are a little tricky, and once again, they're not the most important of the two things. So the way that you do it is you take your formula, and we didn't do this yesterday, but most people can figure it out based on yesterday. If there's two things and there's one thing, then it's the two things on the outside and the one thing in the middle. How many at least have that? All right. Then, this we said was an ionic bond, which means there are metals and there are nonmetals. What are metals in our world? We've been mean to them. They are losers. So how many do they have? They want 0, right? So what I'm going to do, I'm going to take strontium. It has 2, but it's going to lose them. I'm going to put 1 here and 1 there. Okay, what? All right, now, strontium has none, but fluorine's a nonmetal, so it needs how many? It needs 8. So here we go. I'll put these in blue. 1, 2, 3, 4, 5, 6, 7. That's the 7 fluorine had, but how many does it have total now? 8. 1, 2, 3, 4, 5, 6, 7, and now it has 8. Strontium none, fluorine 8. Who had that one right? Raise your hands. You guys didn't even watch, but I think that paper went in. That was a no-looker. Just Kobe. I think Kobe looked normally. Maybe he didn't. All right. So not too bad. Is this one going to be exactly like that one? No, because it's not ionic. It's a covalent bond. And that really means there's no losers. There's just people that have to share. So here we go. We have a C. I'm just going to get rid of all this. A C, a BR. Oh, I'm not going to draw the lines. That was a mistake. A BR, a BR, and a BR. And then since they're all nonmetals, they all need 8. Are we all right with that? So if you'll look, I'll put these in blue. Carbon has 4 of its own valence electrons. But it needs 4 more, right? Each bromine had how many itself? 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So if you'll look now, each one of them has how many? 8. They all achieved an octet by sharing. So this bromine has 8. This bromine has 8. This bromine, 8. That bromine, 8. And then this carbon also has 8. So individually, none of them had a full octet. But if they just arrange themselves in a certain way, they can all have an octet. The certain way, whenever something from family 4 and family 7 hangs out, the way that they do it is in a 1-to-4 ratio. That's how they can share and meet their octets. Okay, will you give me 5 fingers if you think this is perfect? I can do this. 1 finger if you're completely lost, and then somewhere in the middle. Never the middle finger, please. Unless you feel like it. I mean, it happens. All right. When I was a kid, back then. Okay, moving on. Hi, welcome back to the show, kids. My name's Tom Davidson, and I'm going to teach you more about bonds. Sound good? Okay, most of you gave me 3 or more fingers. That's a good sign. All right, so let's turn to wherever we are in our notes. So that's our homework. Well, that's where you are, I guess. Page 7. Did we do any notes? No, we didn't. Well, you were here, right? Oh, boy, what a... Who teaches this class? All right, so we got a lot more notes than we do in every other hour, but that's okay. And hey, I did pass my test, that observation. Yeah. No, but someone, it was Rasmussen, right? Who's, no, what's your last name? Sorry. Didn't you say, I think you passed your test? Oh yeah, Amelia was here. It wasn't a test. She was observing student engagement. And she said, she didn't use the right word. She said, you had an unsurmountable amount of student engagement. I don't know what that means. But she was like, that was the best engagement I've ever seen in a class, which is funny. I'm going to give you, never mind, I won't. Yeah, right, has she seen Bert's class? That's good. But why I thought it was funny is she was sitting next to Amelia, who was on her phone the whole time. And I was sort of annoyed because Amelia's not even in this class, right? So I was like, but she came from first hour. Moving on, I'll shut up. Okay, we're going to go kind of quick to a certain point, and then we're going to slow way down. But by the end of the day, you're going to be good at one thing, and you're going to think, wow, this is pretty not that bad. I don't know. Here we go. Ionic bonds. I'm in trouble. Oh, I'm not. So ionic bonds do not share electrons. That's because we have losers and gainers, right? Good. So rather, one element gives up electrons and the other one takes them. I guess whatever. So you have your metal giving up electrons and your nonmetal taking them. Easy enough? All right? Whatever. There's lots of drawings. We'll come back and do all this stuff. Oh, why? Why? Electrons are transferred between atoms. Give me the birth class. My own children tease me about Peter Bird. All right, next. By the way, transferred really literally means an electron is moved from the metal to the nonmetal. And you take advantage of that in your life anytime you use anything that runs on a battery. So what do you use in your life that uses a battery? Thank you. Your phone, right? Is that why you're holding it up? Yeah, right. Anyway, your cell phone is simply running because it's constantly going through a chemical reaction to form an ionic bond. But your phone is rechargeable, right? How come? Any ideas? Well, it's a battery. A battery is just a chemical. So here you go. In your phone, you have an electron leaving a metal and going where? To a nonmetal. And that's because it's because nonmetals want electrons. So it just naturally, the metal's like, get out. The nonmetal's like, sweet, move in over here. Life's good. And the electron is transferred through here. And we put we've had physics, we put a thing in there called your phone. And it uses that flow of electricity or electrons to run. But we know it's rechargeable, and here's what happens when we recharge it. we plug it into the wall, correct? So now what we're going to do is we're going to take this. What am I doing? That's an arrow. And we're going to plug it into the wall. That's your plug. And the wall has electricity in it, right? Not the wall, but the wires. All right? And what happens is we use the wall's electricity to force the electron back through to the metal. So while it's charging, we're fighting nature and saying, hey, I can make the electron go the other way if I supply the work, and that work is by plugging it in. And then as soon as you unplug it, what happens? It goes right back the way nature wanted it to go in the first place. Now, here's something really weird. The largest battery in the entire world. Does anyone know where it is?
No.
Thank you. No one does. That's probably loud. It's in Virginia. I have not spelled that in a long time. Is that how you spell Virginia? All right. I went there on a mission. I should remember. Oh. What was that? Oh. He's a loser that didn't go to South America. Okay. Here you go. In Virginia, they have a lake like in the mountains. And they don't actually have real mountains. They call them mountains, but they're hills. And this thing is a battery. And it's very bizarre, but it's the same thing. This lake, during the day, they let the water flow down into a pond. And you're like, how is this a battery? Well, here's how. In the middle of this flow, they've built a hydroelectric power plant. As the water flows through, it creates what? Electricity. And they let this happen all day long. And then guess what they do at night? They pump it back up. At night, they turn on the pump. And the pump does all the work to fill that lake up in the hill. So that in the day, they can let it naturally flow down. And that's because in Virginia, it's hot. And during the day, your electricity spikes because we all turn our AC on. And they need more power in the day than they do in the night. Because after like 10 at night, almost everything that uses power is off. So they just turn the pump on and they do the work to move it back. So then we get gravity out for free. It's the same thing. It is a battery because we can use it to get electricity. And we can also renew it to get electricity, just like your phone. I'm sure that was fascinating. I'm glad that you enjoyed it. Thank you. Let's move on. I wish I could be more like Bert. All right, in ionic bonds, we're going to pretty much say they are always between a metal and a non-metal atom. And that's because they're losers and gainers. So, on your chart, you can do the math, and it works every time. Or if you look at the compound I'm giving you, and you find a metal, then it's an ionic compound every time. Because if the first thing's a metal, the other half will always be a non-metal. All right, let's move on. The metals always want to give electrons. Non-metal atoms generally want to take electrons. Okay, we've said that a lot. I hope you're okay with that. Now, after this slide, we're going to spend a lot of time talking about ionic compounds. Ionic compounds or molecules are electrically neutral. That means that the number of plus equals the number of minus charges. We're going to use this a lot to explain something that is sort of difficult at first and then super easy. So what this slide is telling you, we had SR, an F, and an F, correct? We did that earlier? We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. But really, one of them was from SR on each side, right? So please Stick with me, and we'll hammer this out pretty quick. So if strontium gave 2 electrons away, it gave away 2 minuses, which means it becomes a positive 2. Are you all right with that? So that becomes a plus 2 because it lost 2 negative things. The fluorine gained 1 negative thing, so it became a negative 1. And now, every ionic compound that I have, if I add those numbers across the top, they will always equal 0. And they did. They equal 0. If we did the same thing with table salt, it's Na and Cl. Na gives a dot to chlorine. So what does Na become? Positive, because it lost a negative thing, and it has more protons than negatives now. Chlorine had 7 and took 1, so it becomes a negative 1. So plus 1 minus 1 equals 0. Who's with me so far? So like everyone here and no one there. Okay, that's better. All right, so let's try one. Let's see if you can figure it out. Yeah. Okay, you're good. Today I'm going to ask you to do a bunch of practice ones, and I want you to put them like right here so I can walk around and check to see if you're doing them right. So what I want you to do, based on what I just barely did, and I did those 2 examples where the parts in the top had to add to 0, I want you to figure out if I had sodium, not fluorine, that's not what I want, and oxygen, what would these numbers right here be? To make it add to 0, what ratio of each thing do I need? If you don't know at all, ask your lab partner. If you both don't know, put W, D, K. You're asking your lab partner. And I said, if you both don't know, you can't put we don't. Okay, take a minute. If you have no idea, that's fine, but at least put something. So if sodium and oxygen were to hang out, what would their ratios be to make it add to 0? All right, as I walked around, most people figured out what I was asking. What we were looking for is Na2O. If you put a 1, that's fine, but you don't have to if it's just a 1. And here's the logic behind it. Na has a dot to give away, right? O has how many dots itself? 6. 1, 2, 3, 4. Whoops, I wanted to put it over here. 1, 2, 3, 4, 5, 6. So it can take that one, but it needs another one, right? So this will be a plus 1, this will be a plus 1, and this will be a minus 2. Those things added together equals 0. Okay, we ready to step it up in difficulty? I know, I'm a jerk. If you have aluminum oxide, take a minute and see if you can figure out how aluminum and oxygen would hang out so that their ionic compound added to 0. This one is harder. I saw 3 people that had the right answer. So if you're one of those 3, you should feel pretty good. Now, if you have it, you're like, wait, you didn't count me. Well, I didn't see everyone's paper. So here we go. Aluminum has how many things to give away? 3. If it gives 3 away, what does aluminum become? Positive 3. And that's fine until we get to oxygen. How many does oxygen want to get rid of? Sorry, yeah, thank you. It wants to gain 2, so it becomes a minus 2. Plus 3 and minus 2 will never equal 0. So we have to do a little math. What can make a 3 and a 2 talk to each other? What number do they have in common? A 6. So look up here. How do you make a 3 become a 6? Times it by 2. How do you make a 2 become a 6? Times it by 3. So we have Al2O3. Raise your hands if that sort of made sense. Oh, don't give me that.
No, I said something at the end and you were like, yeah, you're right.
All right, now, Jensen, I'm not picking on you. Annie had a 4 and a 6, which works. Like, I don't know how you doubled everything. It's okay, but it works. But notice a 4 and a 6 can be reduced to their lowest form of a ratio, which is 2 to 3. So she did it fine, just a little bit different. Okay, now, there has to be an easier way, right? There's a way easier way. Super easier way. Jex, she's pumped. She's like, good, screw this stuff. I hate it. Will you look at something? Look right here. Will you notice that this number right here is that number right there? Wow! Stop. Will you notice, now we don't put a negative, but will you notice this number here is right there? Time out. Let's go backwards. Will you notice, I'm going to take this number, I never drew it up here. Will you notice that's right there, and that's right there? Okay, I'm going to teach you. That's how. Do you notice this was SRF2? Look, SR plus 2. There's a 2. F minus 1. There's a 1. Do you see the trend? Okay, this thing is called the drop. That wins. I've never had to do that. The drop and swap. This is called the drop and swap, like it's hot, if you want it to. I made that part up to annoy you. All right, this is called the drop and swap. And what we do is we take the charges of the things, we lower them, and then switch their places. We drop them and swap them. What? Okay, we can swap them and then drop them. Is that what you'd rather do? You're the dancer, not me. All right, so let's do one now with knowing the drop and swap and see if you can do it. Now, there still is a layer of the onion I need to put on top for some of you, but we'll see. All right, see if you can do this one. When calcium nitride, you know you love me actually. When calcium and nitrogen hook up, what's their ratio based on the drop and swap? I got you. Oh, he's got it. All right, so put this in the top right corner. Now, I do know some of you have no idea where the numbers up top come from. It's okay, you have great hair, so it's okay. I will teach you that in a minute, and you'll be like, oh my, this is so easy. Why has he gone so slow? Answer, it's Ca3N2. Which half of you, well, a third of you had. I won't make you raise your hands because you'll feel dumb if you didn't. But a couple of you, at least, you have no freaking idea where this is coming from and this is coming from. And tons of you just barely wrote a 5 right there, right? So let's fix that so it's never a problem. Hold that up and show the class that page. Everyone make sure you're on that page. You with me? We're going to label, oh boy. Okay, hold on. We're going to label that periodic table. Maybe something's definitely wrong. Oh, okay, whatever. Okay, hold on. I'm in trouble. Okay, here we go. Does everyone have this part open? I'm going to give you the charges of each family. Are we ready? Sorry, excuse me. Here we go. In family 1, we know they had 1 dot, right? Which means they lose 1 dot. Which means everything in family 1 becomes a what? A positive 1. So put a positive 1 above hydrogen in the table. Well, not in the table, above the table. You can do it below, by the way. If you've written stuff above, do it below. I don't care. All right, look. Everything in family 2 has how many dots? 2, which means it'll lose 2, which means everything in family 2 becomes a what? Positive 2. Any guesses what happens in family 3? Oh. They lose 3, so plus 3. Now stop. Don't keep on going because you get it. Because right in family 4 is where we switch from losers to gainers, right? So here we go. Family 4, they're kind of your uglies. Good. Whoever said that, good job. They're plus or minus 4s. All right, even better, thank you. How do you know which is which? If it's a metal, it's a loser, so it's a plus. If it's a non-metal, it's a gainer, so it's a minus. Okay, then, don't put a 5, because it's not a 5. Please look. These have 5 dots, which means they really want to gain 3. If you gain 3, what do you become? Negative 3, then negative 2, then negative 1. Put those on the top. All right, now, Amelia, you ready? Now the drop and swap's a piece of cake, right? Because you find the element, you write it down, you put what it is above it, and then you drop them and swap them. We're going to do 3 examples, and we're going to work on our color and shape coordination. Are you ready? You find the formula of the pairs. There you go. So there's 3 problems. Match the red circles, the green squares, the blue triangles to find your formulas. Was that confusing, Post? Okay. All right, did I do circles first? All right, so we did NAP, N-A-P. We had a +1 above NA, a -3 above that, so NA3P. Who had that? Raise your hands. I don't know where I've gone wrong. Blue triangles, we had CaCl. There's a 2 above Ca. There's a 1 above Cl. So it's CaCl. 2. I was going to fall over. And then our green one will annoy you, but that's fine. That's what life is. AlN. +3, -3. So you put a 3 and a 3. But in chemistry, we reduce it. Same lesson that Jensen had. If it's ever the same number, you don't need any numbers. Now, on the test, if you put Al3, N3, I'm not marking it wrong, but a 3-to-3 ratio is really a 1-to-1 ratio. All right, raise your fingers again. 5 if you're awesome on just this piece. 1 if you're completely lost. Okay, that's a lot of fingers. That makes me feel better. All right, the ability to find the formula based on these things is super important. I'm going to steal hers real fast. On the back, you have 100, and that's because I love you, by the way. And you're like, why would he give me so much work? You have 100 things where you have to take word formulas and find their chemical formulas. Will you turn to the very, very back page? The very, very back page happens to be the second, page 19. I don't know why. It's auto numbers. How is that even possible? What's that? Yeah, there we go. Everything's all about burnt. All right, am I still recording? Good. There's not very many that you can do yet with just this superficial knowledge we have, but we can do number 78. Circle number 78 and then number 88. Will you try and do both of those just based on what you know? Writing the formula and then dropping swap. 78 and 88. Now, that page looks overwhelming, but I promise we're going to spend at least 2 school days working together on how to do it. And it's not hard. Like, over half of these are just drops and swaps. You just don't know the words. So like number 77, that's a drop and swap. You just don't know what hydroxide is yet, and we'll teach you that. 79, that's a drop and swap. It's just you don't know what chlorate is. So we'll learn all those things. Just be patient, and it'll work out in the long run. Okay, let's turn back now and talk about covalent bonds. Do you think that ionic bonds and covalent bonds are the same? No. How come, Raquel? It's our same argument yesterday. Do you remember? If they have different names, they probably have different properties, like different dances. that got ugly fast, so we won't go there. But you can't apply what I just taught you about ionic to covalent bonds because they behave differently. In an ionic bond, we have things that lose and gain. In a covalent bond, we have things that share. Oh, this is the wrong slide. Hold on. The wrong thing. All right, and then we'll click through like 50 slides to get where I want, but whatever. If you missed anything, just read real quick while I'm going through this. Looks good. Okay. No. I just read it was 55. Am I blind?